I wanted to put together a brief video for you showing you once again how to use this table to solve z-score problems. The important thing to remember, there are three things to remember in looking at this table. The first one is that the table is always going to give you the area, as it says here, the area from the mean to a given z-score. That's the first thing to remember about this table. The second thing to bear in mind is that the total area under the curve is always equal to 1, never anything other than 1. Why is it 1? Because it accounts for all the possible scores that we might get. The third thing to remember is that always the normal distribution is symmetrical. Why is this important? This is important because it leads us to the corollary then that the area from the mean all the way out to the highest possible z-score is going to be 0.5, and the area from the mean to the lowest possible score out here is also going to be 0.5. Again, because the distribution is symmetrical and because the total area under the curve is 1, we know that the right-hand half of the distribution is equal to 0.5, a probability of 0.5, and the left hand is also equal to 0.5. By way of example, we can say that half the scores are above the mean and half the scores are below the mean. All right. So how do we use these three, or maybe four, depending on how you count it? How do we use these three principles to solve any kind of a z-score problem? Well, there are a couple of z-score problems that we might want to solve. Let's take a look. Here is my normal curve in the wrong spot. I can move it down here. All right. And let's take a look. So the first kind of problem, oops, it doesn't really matter what color it is. The first problem is the problem right from the table. We're asked to find out the probability that a score is between the mean and a given z-value. In that instance, we just simply look it up. We look up that probability in this table directly. We don't need to do anything else because we're following exactly what the table shows, that area from 0 to z. Same thing here, that area from 0 to z. All right? So if we have a z-score, let's say of 1.12, we'll make it. Z-score, how do we use the table? 1.1 is over here. 0.2, we're going to get that from over here. And where that row and column intersects is the probability that we're interested in. And in that case, the probability is equal to 0.3686. That's the probability that the score is between 0 and a z-value, that's a z. Let me write it out now, 1.12. So that's a real easy one. There's nothing extra we have to do. Let's take a look at another one. Again, I'll see if it pasted in correctly. Now let's say we're interested in the probability that a score is greater than a score is greater than a z-score of 1.12, and that's this area over here, right? This is again why we are always going to be drawing out these distributions. You got to draw out the distributions, okay? Otherwise, you really don't know what you're figuring out. So we're interested in the probability that a score is greater. The score is greater than 1.12. So we don't show that on the table. The only thing we show on the table, again, is this from 0 to a z-score, not from z-score out to the tail. But we can compute that easily, remembering that the total area to the right of the mean that I have in blue here, the total area to the right of the mean is 0.5. We're given in the table this area over here, And again, that is 0.3686. So we have to subtract 3.3686 from the total. And I'm not going to do that. Well, maybe I will do that. And that's going to compute to 0.1314. So this area over here, this area that I've got shaded in green, that I'll highlight it again in green, that area over there is 0.1314, and that's how we figured that out. Let's take a look at another problem. Okay, in this case, we're interested in the probability that a score is in this area over here, this area over here. And we'll make it, again, a z-value of 1.12, but this time negative 1.12. Why negative? Because we are to the left of the mean. We are to the left of the mean. Well, again, our table doesn't give us these negative z-scores. All these z-scores up here are positive values, right? These are all positive values. But we're going to remember that the z distribution is symmetrical. So whatever we figure on one side, we figure on the other side. And we solve the problem exactly the same way, and the answer, in fact, is exactly the same. This time, we're going to have, well, it's not this time, it's exactly the same, minus 0.5 minus 1.12, and that will again equal I didn't do that right, sorry, I put down the z-value. 0.5 minus 0.3686, the value from the table, and that again gives us that value, 0.1314, and that is the same value over here. Okay. What else can we figure out? Well, you might get a problem that looks like this one. Let's say that we're looking to find out the probability that a z-score, a given z-score, is less than 1.12. That would be the probability that we are in this area. I'll use arrows this time, it's quicker. All right, how do we solve this kind of a problem? Well, same way, right? Same way. We're looking for the probability that a score is less than 1.12. Now, again, we don't know from our table, what this shaded area is. But we know from the rules that I just outlined, or outlined a minute ago, that this whole area here, this entire area here, is equal to 0.5. And we know, because we've calculated it, what this area here is equal to. So we can say, therefore, that the probability that that any score is less than 1.12 equals 0.5 plus 0.3686. And what is that? That is simply the blue area plus the green area, right? And that equals 0.8686. So the probability of getting a score that is less than 1.12 is equal to this guy over here. Okay? And similarly, let's do another one. The probability of getting a score between two values Okay, let's take a look now at one more kind of a z-score type problem. We want to know the probability of getting a score between two values. Between two values. I hope you can imagine now how you would figure this out. This is simply going to be the probability of getting a score between 0 and this lower z value plus the probability of getting a score between 0 and this higher value of z2. We would simply add this probability, whatever it is, to this probability over here. Let's figure that out with a real example. Let's say our z-score is going to be, as it was before, 1.12. So the probability that we are between 0 and 1.12 equals, what was it, 0.3686. Right, I'll color that in with yellow so we know what we're talking about. Plus, let's try another z-score. How about if we use a z-score of 0.25. We'll just use 0.25 for the heck of it. So let's look up the probability for this area in here. Let's look up that probability, 0.25. 0.25, we're going to check in our table, is 0.2 and 5, and they intersect, I believe, right there. I believe that's the one we're looking for. So 0.987, or 0.0987. And we'll color that in with blue, as we did. So if we add those two up, we are going to get 0.4673. So the probability of getting a score between a z-value of 0.25 and a z-value of 1.12 is this over here. And I'm sorry I misspoke. This is actually this would be a negative 0.25. Doesn't make any difference because the distribution is symmetrical. But in case you're wondering, since we're less than 0, the score obviously the z-score has to be a negative. Okay, so that's how we figure out that kind of a problem. One more type of problem to solve, and these are maybe a bit trickier, although really not that much more tricky. We'll paste our distribution again. This time we are given a proportion. We're given a proportion, or a percentile usually, and we're asked what is the raw score associated with that. So we are given a value that represents this here. Okay, whatever that is, and we're asked to determine the raw score associated with that. How do we solve that kind of a problem? Well, we go back to the table. Let's say we are looking for the 90th percentile. Let's say this is the 90th percentile, okay? How do we deal with that? Well, the thing to remember is that the table doesn't go up to the 90th percentile. The highest value in the table, I don't show it here just for space purposes, but if you take a look, you'll see that the largest probability area that you have in this table is 0.4990. 0.4990. So what do we do with that? We need the we can find out the 0.900 we can find out the 0.900 probability, close to the 50th percentile if we want, I guess. You all know what that's going to be anyway. That's going to be the same as the mean. But how do we get this 90th percentile? Well, what we have to do is take what we know about the distribution. We know that the distribution is symmetrical. So at the end of the day, we're really just interested in, to get this 90th percentile, that's going to be this area over here, 0.5, plus whatever that area is over there. Okay, in this case, it's going to be 0.4, because 0.4 plus 0.5 would give us the 90th percentile. All right, so we're going to look for that 0.4. This time we have to look in the body of the table, because the margins of the table are just giving us the z-values. We need to get the z-values from a given proportion. So we'll look through the table here, and let's see, what do we have? We have over here, we have 0.3997 or 0.4015. 0.3997 is closer. So what's the z-value associated with that? That is going to be 1.28. 1.28. So I'll scroll back down here. 1.28. And that's our starting point. That's our starting point. We're going to plug that value into the z formula, and we're going to compute the raw score. I can't do that here for you. Why? Because I don't have the other two key ingredients of the z formula, the mean and the standard deviation. But let's take a look at the z formula. Z equals the value in question, the raw score minus the mean of the distribution, all divided by the standard deviation. And we can simply transform that algebraically so that we're going to get something that looks like this. X equals S times Z plus the mean for the distribution. And what we'll do to solve the problem is we'll take our Z value over here, plug it in. So we're going to get S times 1.28 plus the mean. And that's going to give us our value for X. Again, I don't have that here for you because I don't have standard deviations and means, but you can try that with a problem, and you should get the correct answer using that formula. All right, I hope you found this useful. I know I went very quickly, but my guess was you didn't want to spend about a half an hour listening to me talk, and I didn't want to spend 2 or 3 hours or more putting together a fancier video. So hope that helps, and we'll see you in the next video.